Guys, welcome to my YouTube channel. This is ETA, Easy Teach at ARC. So I'm going to be your host. I'm going to be your teacher. My name is Matumba Dibani. So I have something very exciting today. I'm going to be teaching you guys physics. I'm going to be teaching you guys a very interesting topic in physics. I'm going to be teaching you guys vectors and forces. I'm going to be teaching you guys vectors and forces. Now, what are vectors? A vector has a magnitude and direction. A vector has a magnitude and direction. Vectors and forces. So a vector has a direction and a magnitude. What is a magnitude? It is a it is a scalar value. Let's say, for instance, if I move from point A to point B, and say if I have traveled 10 kilometers, that is the distance. And the distance is not a vector, it is a scalar. From here to there, let's say it's 2 kilometers. From A to B, that is a vector magnitude of a distance. If you can check from point A to B, there's a specific direction. So that's it. That's what we call a vector. So a vector distance is called a displacement. So it doesn't matter how your distance was, whether you travel, come back this side. So what matters is where you started and where you ended. That is the vector distance, which in this case we call it displacement. So moving right along, let's say, for instance, you have two vector displacements, A and B. If you come to the Cartesian plane, and you put this is A, this is B. Now the vector displacement, in case if these are distances, vector C All right, moving right along. We've talked about vectors. Now we're gonna start a very interesting topic, forces. Forces. Now, what is a force? A a force can either be um, gravitational force, it can be a normal force, gravitational force G, normal force Fn, can be frictional force, can be applied force, it can be applied force, is represented by letter F. It can be tension, which is T. So these are the typical forces that you will encounter in a system. Or let's just say in a closed system. Now we have the so-called Newton's laws. Newton's law, the first Newton's law states that a body will remain at rest or continue to move at a constant velocity unless a resultant force acts on it. So we will have balanced forces at constant velocity or at rest. Okay. Number two, Newton's second law, F equals ma, meaning whenever there's a resultant force, because Newton's first law said body will remain at rest or continue to move at a constant velocity unless a resultant acts on it. Now, what happens when a resultant force acts on that object? We get a resultant force, and that resultant force is directly proportional to the mass of the body or the mass of the system, and it's also directly proportional to the acceleration of the system. So what happens is once there's a resultant force, note this one, once there's a resultant force, there is acceleration. Now, Newton's third law talks about a reaction pace. So whenever there's a force acting on an object, whenever there's a force acting on an object, whether it's moving or whether it's stationary, there is always a reaction force that acts. All right. So what are the equations that governs motion? We have equations of motion that we're going to talk about. It's a very interesting topic because it involves a lot of maths and functions, and I will talk about functions a lot in this course and also in my maths paper 1 course or subject. Sorry. We have equations of motion. Okay. I think there's an R right there, but no problem. Velocity final is given by velocity initial plus acceleration multiplied by the change in time. So whenever there's a change in the velocity, or whenever there's a force that acted on an object, there will be acceleration over a specific time period. And that will give us that equation number 1. So in order to get, so that's the equation. So we also have this equation. Equation 2. So the third equation, they say displacement is given by V initial change of time plus 1/2 acceleration times t squared. But technically, to get this equation, if you for those of you who are going to be in university next year, you will learn something called integration. If you integrate that equation, you will get this equation. You will get the displacement equation. So if you integrate a function, what you're trying to do is you are trying to find the area under that graph. You're trying to find the area under the graph. So velocity is the area under displacement is the area under the velocity time graph. So when you integrate, you're actually trying to find an integral area under the graph. But that's not what we're going to do. And velocity is given by distance over time. So distance is given by velocity times time. So if you have a, velocity versus time graph, that area there over a specific time is your displacement. It is your displacement. And hence you can see area is length times breadth. But if it's a rectangular profile, then it will be length times breadth multiplied by 1/2. That will give you the area. As a result, if you rearrange that equation, you will get, if you rearrange and go back, you will get velocity equals distance over time. Now, this is a fraction. If you have a displacement time graph, the slope, which is change in displacement over time, that slope there will be your velocity. Again, to prove the very same theory, if you want to find the slope on an equation, you can solve the derivative of that function. So for instance, let's try to find the derivative dx d in respect to time. Let's find the derivative of the displacement in respect to time of equation 3. So we will have vi on this equation. We'll be left with vi when we integrate this equation. We'll be left with vi plus, if you integrate this equation, you'll be left with, that 2 will go down, so it will be 2 times 1/2 times acceleration times time. So the 2 will cancel. So you'll be left with the v initial plus at, which goes back to that. So that's a proof. All right, moving right along. So before we move, let me give a summary, a very important summary. The displacement is given by the area under the velocity time graph. The displacement is given by the area under the velocity time graph. And the velocity is given by the slope of a displacement versus time graph. Those are the important points. Those are 2 important points that you can get. Those are the 2 important points. Please remember those 2 points. So let's say, for instance, if you check the equations very well, you will notice, you will notice that displacement changes parabolically over a specific period of time. So this is how your typical displacement time graph will be like. This is how your displacement time graph will be like. It is parabolic. Let's say, for instance, if you throw a ball upwards, initially it will be at a displacement 0, and then it will move up and reaches the point of equilibrium, to reach a point whereby your ball or your object that you've thrown upwards will appear as though it is stationary. As we have said, the slope of the displacement time graph is the velocity. Where do we find, if you throw an object upwards, where do we find the maximum velocities? So in other words, where do we find the maximum slopes? The answer is the maximum slopes is at the initial and the final. And note that the initial velocity will be the same magnitude as the final velocity. However, it will be in a different direction. And what happens when your object reaches a peak? Your slope is relatively flat. Your instantaneous slope is relatively flat. So your velocity will be 0. So if they ask you in the exam, what is the velocity when the ball or when the object starts turning? The velocity will be 0. And what will be the velocity as just before the object hits the ground? That is the maximum velocity that you're gonna get. You're gonna get the maximum velocity. So in order to get the equation for the velocity of that graph, you have to find the slope, or the so-called the derivative of that graph, which is your velocity equation, which is your velocity. All right. So moving right along, the other observation that is very interesting, let us go to the velocity function. Velocity function. Your velocity will change over a specific period of time. However, in this case, my bad. Let me show you how the velocity will change in this case. In this case, if you're throwing a ball, if you choose upwards as the positive direction, it means it means at the start of time, your velocity will be at a max. For instance, let's say if it started there, velocity initial, it will be there. And then your object will move at a constant acceleration, which is acceleration g. And then when it reaches that point there, your velocity will be zero. As you can see, your velocity will be zero. And then your velocity, which is a vector, it changes direction to a negative. Because now, once the object reaches a peak, where it will fall down. When it falls down, it will be moving at a negative direction. It will be moving at in a negative direction. Now, let's say if this is area 1, area under the graph, area 1, area 2. As you can see, as the object is moving from that time to that time, your displacement, you will get it there. So it will be that area. And that will be the displacement when the object has reached its peak. If you find the area under the velocity time graph, you will get the displacement of the object from the ground after you've thrown it just at the equilibrium point, at this point. And then what is the final displacement when the ball comes back to the ground? The final displacement is actually zero, because you need to add that area plus that one. That is a negative of that one. So the total area will be area 1 minus plus area 2. This is the displacement. However, area 2 equals equals minus area 1. So you have A1 minus A1 is equals to 0. So your displacement is 0 at this point. At this point. At this point, your displacement is just the area under that piece of a graph. So moving right along, I think we are done explaining equations of motion, which is a very interesting topic. So we will have is a very interesting topic. So one last topic is the force itself. So let's talk about gravitational force. G. According to Newton's universal law, He says, in a system with two objects will always exert an attractive force towards one another. There's always an attractive force towards one another, which means if I'm sitting next to a person, there's always an attractive force that is exerted between me and that person. And what Newton said was that the gravitational force that is exerted between two objects in a system, he said they are directly proportional to m1 to the product of the masses, and also directly proportional and also inversely proportional to the square of the distance between the two objects. And then we have also been introduced to the so-called gravitational constant. This constant was derived after a very thorough calibration that Newton did when he was doing his gravitational tests on objects. So he found out that the gravitational constant is 6.67 by 10 to the power of minus 11. So we're gonna be focusing on finding the forces between two objects in the next segment. So if you have any question, if you have anything that you want to raise, please feel free to comment. Please feel free to write whatever question you want me to address, and I will address it. I will address it instantly. So guys, thank you for watching my YouTube video. Thank you for participating. I hope to see you guys in the next segment. Please feel free. Please feel free. Please feel free and enjoy this video. So that is the equation for the force. I forgot to put it down. That is the equation for the force between two objects. Force of gravity between two objects. The reason why the force of gravity on Earth is massive, it is because one of the product, which is the mass of the Earth, it's humongous, it's very big. It is very big. That is why the force of gravity is very, very massive, which is typically 9.8 kilonewtons, which is 9.8, sorry, not kilonewtons, 9.8 meters per second squared. That's acceleration. Your acceleration is 9.8. So there we go. So on the next segment, please feel free. In the next segment, if you have any question, please feel free. Guys, thank you for watching my video. I'm still your host, Matumba Dibani. Please like, follow, and subscribe for more that is coming on your way. Thank you. Thank you, guys.